When the Greeks started studying geometry about 500 BC, they needed to create shapes that were perfect shapes or had perfect geometric properties. And so they used a straight edge and a compass because circles are very useful. A compass makes circles, so when they made a circle, we have radiuses. Here's a radius. The radius is the distance from the center of a circle to the outside of a circle. That's the radius. And if we take any radius in a circle, it's always going to be the same. Okay? So circles are useful because all the radiuses in a circle are the same. So if we want to make congruent line segments, circles are really useful because all the radii is plural for radius. All the radii in a circle are congruent. All right. Well, congruent circles are useful also because if we have a circle or we have multiple circles here like this, and we know these circles are the same, well, if the circles are exactly the same size, then that means their radius have to be the same size. So the radii, we could say, the radii of congruent circles are congruent. So now if we have two lines that are in the same circle, they must be congruent. If we have two circles that are the same, then that means their radiuses must be congruent. All right. Well, the congruent circles in constructing the perpendicular bisector. All right. Well, how do we make a perpendicular bisector? That's something we did in our lesson here. Well, let's take a look at that here. So if we have a line, something like this. So here we have a line. If we want to find a perpendicular bisector, something that's perpendicular that goes through the middle here, what we need to do is we need to construct two congruent circles. So if we open up our compass more than halfway and we draw a circle or a part of a circle, there's our part of a circle, and we construct another congruent circle on the other side here. Now mine happen to be going through A and B. They don't have to. But if we draw two of the same circles, now those are part of the same circles. They can continue on, but we don't exactly need the whole other side of the circle. But since those circles are the same, we know that their radiuses are the same. So let's make this a nice clean line. So if we take this line right here, and we take this line, we take this line right here. Okay, so those are the same distance, all right? So because they're both radiuses of the same circle, okay? Actually, the radiuses of two different circles, but that are the same size. This is the radius of this outside circle here. This is a radius of this circle. The circles are congruent, so those line segments are congruent. And so we end up with an isosceles triangle is what's really going on there. And so in that isosceles triangle, if we draw in the line that goes through these 2 points, then that is a perpendicular bisector, okay? Or it's pretty darn close. Now when we construct these by hand, I'm working on an iPad here, and it really doesn't want to. Let's see. It's a little tricky because I can't use a compass so well on an iPad. But anyways, all right, so what we get here is we get a perpendicular bisector. It cuts this line in half, and it's 90 degrees perpendicular. So when we construct these circles, we see that all the points on this line are equidistant from A and B. Let me see if I can do one more circle to convince us of that. So there's a circle from B, and I'm going to do the same size circle from A. All right, pretty close. Notice they both cross on this. So those are equidistant from A and B. All right, so they're the same distance. And so when we have a line that's always equidistant from A and B, let's get that to stay. Will you stay there? All right, then that makes it a bisector, and specifically a perpendicular bisector, okay? So we could learn lots of things from this, but the idea is if we have congruent circles, we get congruent distances or congruent lengths, specifically in the radius, but also in these lengths of other lines in between. So, all right, well, so just a little quick recap. We've learned here that we've got the congruent symbol. This is our congruent symbol. That means congruence, okay? Construction, when we do a construction, we're using a compass and a straight edge. So when we construct things in geometry, doesn't mean we're using we're getting out saws and hammers and building a house. It just means that we are using a compass and a straight edge, okay? And we get, equality statements, things that are always true, always equal. And so when we say two lengths are equal, we say something like AB equals CD. This is an equality, the statement there, all right? It's different than a congruent statement. A congruent statement would be AB, the line segment AB is congruent to CD. This is the name of AB. Without the bar, it means the distance between. So distances are equal, line segments can be congruent, all right? So we've got our radii, all right? So again, we've talked about that. The radius here is the distance from the inside, from the center of a circle to the outside, all right? So that's a radii, okay? All right. Radius is singular, radii is plural, okay? Array, little reminder, array is a line or part of a line that goes in one direction, has an endpoint, and has a point that it goes through. So this is ray AB, and we draw an arrow over it. You cannot call this ray BA. That would be wrong. All right, because this ray starts at A and goes through B. So it starts at A and goes towards B. All right, cool. Well, those are things that we've been using here. Let's look at a couple little examples just to see how we're using this. So we're going to be getting some specific instructions of how to create things that we know are the shapes we want to create, okay, or have the properties that we want. So let's try to make a rectangle here, all right? So we've got some instructions here, all right? You can try this if you have a compass. We want to construct congruent circles centered at B and C with radius BA. That's important. So we want radius BA and centered there, all right? So we're going to open our compass up to the length BA, okay? And it gets tricky sometimes when it's small. Let me zoom this in a little bit, okay? There we go. Okay, so we open our compass up to that distance, okay? And let's put a circle centered at B and A. Let's try that again. Made a mess there. So we get a circle at B and C with the radius AB like this. Now if we construct another circle that is centered at B and A with a radius of BC. Okay. So now we want a radius of BC. So let's get a bigger circle there. Now as we do this, we can see that we don't necessarily need the whole circle because we're looking for a point over here and we're looking for where they meet, all right? Trying to make a rectangle, so we might ask ourselves, ooh, is that the point we're looking for right there? Not quite, all right? But if we bring that same size circle up here, and let me make another circle the same size, so it's same radius as B and C. Okay. So I'm copying that length. So I now know that if I draw a line segment from this point here to A, then that should be congruent, and I should be able to, it should be parallel, all right? So, all right. So it looks pretty good there, pretty close, all right? And then we get our fourth line there. So there's our rectangle, all right? Okay, so we get these two arcs, these two big circles here, and where this circle that's centered on A crosses this little circle, that's where our rectangle lands, okay? All right, if we take a rhombus here, a little more practice. If we take our rhombus here and we draw in our diagonals, so we have AC and we have BD, okay? And then we take our compass and we open it up to, let's see, we're going to open it up to AB, and we're going to draw a circle centered on A. So there's our circle centered on A, or the part of the circle that we need. Next, we need a center circled on C. That's the same length as CD. So let's try that. Okay. So the circle would continue on, but that's going to be enough for seeing what we need to see there. Okay. Well, what do you notice about it? Where do they intersect? Well, they intersect at these points, B and D. Okay, so they intersect at those points. And what does that mean? Well, can you see that this is our perpendicular bisector like we did a few minutes ago? So the line we get here is a perpendicular bisector. This fish-looking thing, I think it looks like a fish. Don't you think it looks like a fish? Here's our fish. Here's our eyeball. There's our little fish. So that shows us that the diagonals of a rhombus are perpendicular and they're bisectors of each other. All right, one other thing here is that we're going to review and use in this assignment is solving systems of equations. So remember these from Algebra 1? Well, when we solve a system of equation, we take an equation like, let's look at this bottom equation here. I'm going to cover up the top one for a second here. Let's say that we knew what y was. And maybe if I told you that y was 10, could you plug 10 in and solve for x? Sure, we could subtract this 10 and solve it for x and things like that. Yeah, we could do that, right? Well, what if I told you 10 was, 170? Sure, whatever. Okay, so we could solve it. If you knew what y was, we could solve it. Well, what if I told you that y was equal to, not 10, not 100, but y is equal to 6x plus 4? Well, in that case, we could take 6x plus 4 and plug it in for y, because that's what y is equal to. Make sense? All right. So we can plug that in. When you substitute it, you should always substitute in parentheses. Sometimes it won't matter. Like right here, it doesn't really matter. But if we have something out here that we need to multiply by, then we need to do that. If there's a negative, you need to distribute that. In this case, there isn't anything, so we can just rewrite it as 9x plus 6x plus 4 equals negative 1. Let's combine like terms. That's 15x. Now let's get that 4 out of there. Subtract 4, leave the x's alone. 15x equals negative 1 minus 4. Careful, that's negative 5. And now we have 15 times x. We want to get x all by itself, so what do we want to get rid of? We want to get rid of the 15. So let's get rid of that 15. It's being multiplied right now. So let's divide by 15. Okay. And that 15 goes away. And what is 5 divided by 15? Well, look at it. You don't need a calculator. Just look at it. It's a fraction. We write it as a fraction because it is a fraction. 5 divided by 15 is 5/15. That is the answer. Okay, so we can say that x equals negative 5/15. But we can simplify that. We can divide the top by 5 and the bottom by 5, right? 5 goes into 5 once. 5 goes into 15 3 times. So negative 1/3. All right, are we done? No, not quite. we've got to find out what y is. So we've got to plug that in for y. So let's do that. Okay. So we know that a y equals 6x plus 4. Well, we know what x is, so let's plug that in right there. So y equals 6 times negative 1/3 plus 4. 6 times negative 1/3, well, if you want, that's like 6 over 1. When we multiply fractions, we multiply straight across. 6 times negative 1 is negative 6. 1 times 3 on the bottom is 3. And we know that 6 divided by 3 is 2. So this is negative 2. And negative 2 plus 4 is just positive 2. So we found out that y equals positive 2. There you have it. Okay? Now what did we really find? Well, we really just found a point. We found the xy coordinates of a point, negative 1/3, comma 2. That's the final solution. Okay? So when we're solving a system, remember, we're finding out where the two lines cross. So if we graph these, the first one, y equals 6x plus 4, looks something like this. Okay, here's 4, and we're going up 6 over 1, so it's pretty steep here. Something like that. And then we got this other equation here. If we solve this up, subtract 9x, this is y equals negative 9x minus 1. Okay, so let's come over here. Y-intercept with negative 1. And a slope of 9x, so something like this. And where do they cross? They cross at the point negative 1/3, comma 2. There it is. Okay? So the solution to the system is the point where they cross. There you have it. All right. Well, there's some things to remember, some things that we'll use in our assignment coming up here. So hope that helps. Thanks for watching.